Hi everyone and welcome to this video. In this video I bring a very interesting topic which you use but you are not familiar with that in your real life and you use it for fun purposes. Okay, so just recall what you do with AI in your real life. Okay, so that is generative adversarial networks. I will talk about the basics. I will give you the overview of making familiar with GANs, but don't think this is a very complex topic, a very easy topic. I think it's an easy concept. People think about neural networks very hard. No, it's very easy. I will guarantee that you will be if you see this video clearly, you will get intuition about what actually GANs are. Okay, but before that, I have divided this video into section which will description down box below, which will the table of contents, so you can jump directly onto that if you want. Okay, so first of all, let's talk about the real life. What are the examples in the real life? Let's say you use image filters in real life, means maybe your phone camera or maybe a Snapchat. They'll make your face like a cat or a dog, or maybe you have some kind of application which you give your photo as an input, and after that, after some seconds, it will give a video that something kind of a song. You are just speaking, rather you're not speaking, but you are speaking. You are just moving your head here and there. So this is what GANs are. So the first application is image filters that make your make your face as a cat. The second one is making Mona Lisa back to life. Means you can make Mona Lisa back to life. Just it's very kind of thing. Means you just give a picture to the GAN and GAN will simply make Mona Lisa kind of a speak. You can speak to back to the person like that. It is called the deep fakes. So you can do that, or maybe you want image where the bird, the famous bird, maybe I don't know the name of the bird. The bird is sitting on the branch of a tree. Just you write the text, the bird is sitting on the branch. So you give to the GAN and GAN will generate that image that you are thinking. Means not you're thinking, I could say you just write a bird sitting on a branch. As you can see on the screen, that bird sitting on a branch, you write the text, and after that you get a picture of a bird which is actually sitting on the branch, just using the text to image translation. So I hope that is very interesting. There are a lot more applications which is used in the medical, many of the real life kind of etc., and many of the application uses, and this is emerging kind of a domain. It's a little bit growing, many researchers going on, and this was GANs were introduced by 𝙃𝙤𝙘𝙞𝙀, which I like to read the research papers of this author, and he's a very great deep learning practitioner or researcher available here. Okay, so what are GANs now? GANs are just like I've said, that maybe you know natural language processing, maybe you know computer vision, and it is the framework of a machine learning or a deep learning. So it is a framework of a deep learning. Just like that, means in kind of it consists of two neural networks. The first one is generator and the second one is discriminator. And you might think, hey Ayush, what are you telling? I'm not getting that. I'm not getting that. Means this is very simple. I've taken the name neural networks here, and don't worry, it's very simple. So you have two players. Okay, so let's assume there's two players. One name is generator and the second name is discriminator. Okay, so what happens is generator here means the player try to fool the discriminator. Means here we have a discriminator and here we have a generator, and it tries to fool the discriminator. You can see over here that we have a discriminator which generator tries to fool him. Okay, how he fool? He fool by generating fake examples that looks like real. And this might feel very complex. This is very easy to say, but it's kind of a little bit hard to grasp. But let me make you familiar with whatever I'm saying. So you have a generator that will generate the fake example. It will generate actually the fake example, but it will look like a real, means a realistic example. So generator, what it does, it simply give the fake example, but it looks like real. And the discriminator work is to do not be fooled by the generator. Means it always tries to classify the image as a fake or a real. And you might think, hey Ayush, what are you telling? Here, discriminator is the classifier which will classify the image generated by generator and the real image. So let's say generator here generates the image here, let's say a cat image that is fake example but is looking like a real. And here is discriminator setting, and discriminator simply says, and we give discriminator to a kind of a real example, a real cat, and here we have a fake cat to the discriminator. So what will happen? Discriminator classify the real and a fake example. Okay, so generator gives fake example to discriminator, and discriminator try to classify whether this example is a fake or real. And if he say fake, so again this discriminator have to do some more work, generator have to do some more work, and then give to discriminator. Again discriminator says it discriminator says it is fake, so again it goes here. So here generator is trying to fool the discriminator by trying to make more realistic examples, and discriminator aim is to do not be fooled by the generator, and in this way they do competition. They both players are on the ground. They both try to, one is try to fool and one try to not be fooled. Okay, so in this way they just improve themselves, and it's just a mini-max game. I think you have played that, but I will ask you to search on internet what is the mini-max game. Okay. So it is just a playground. You have a playground, and where the two players are there. First one is generator, and the second one is discriminator. And generator always tries to fool the discriminator by generating the fake example that looks like real, and discriminator always tries to classify the fake example with the real example. Okay, so I think that you got a fairly overview of intuition about GANs, and that what the GAN is. GAN consists of two neural networks, which is known as generator and the discriminator. And in this case, we have seen that generator tries to fool the discriminator, and discriminator do not be fooled by the discriminator, by the generator. Okay, so I think that you got a fairly intuitive idea, and this might feel intimidating. So watch this. So rewind this video again if you're not able to recapitulate. But if you didn't dare to understand, don't worry about it. Just go with this video. At last, I will give you the resource circle. Learn more about that. Okay, so so let's specifically talk about each of them. And first we'll talk about generator, and then we'll talk about discriminator. So what actually generator is? Generator is just a neural network that tries to generate the fake example that looks like real for fooling the discriminator. Okay, so how it generates the fake example? So it is just like this. I'm taking one example. You go something. You don't know where to go something, but you have to go somewhere. Okay, or let's say you have to paint something, but you don't know what you have to paint. Just like the situation of the generator has. What we do, we give a noise vector. We have a noise vector. Maybe it can be 100-dimensional, I don't know. So we specify that. So we give a noise vector. We give a noise vector to the generator, and generator tries to generate some noise examples, a figure of, let's say, 28 by 28 image from that vector. And then it gives to discriminator, and discriminator classified as a fake example. So it then come back with some feedback, and then it will simply update a little bit, and then give that, update a little bit, then give back, etc., etc. It will happen, and at last discriminator will be fooled, or maybe the generator will be fooled, not be able to fool, and kind of happen. So one is trying to fool the discriminator, and discriminator always tries to not be fooled by the generator. So what we do, we give a noise vector z. We give a noise vector z, just as a convention, we denote as a z, to the generator, and generator generates some noise examples, and let's say example of 28 by 28 pixels, it generates from that noise vector. And then we give to discriminator, and as well as we give a real example to the discriminator. As you can see that we are not showing a real example to the generator. Generator is just like this, paint something, but it don't know what to paint. That's where the problem here. That's what the aim is. Means you have to go something, but you don't know how to go something. like that. Okay, so also give real examples to the discriminator as well as fake example, and the discriminator will say, okay, it's fake example. Then using a cost function or classification error, we will take out a gradient or the partial derivative, as you can see on our picture. So you take out a partial derivative. If you don't know about that, I've already asked you that you should know gradient descent, but partial derivative you should not know. But in general, let me give you a hint. So a gradient is just like this. The partial derivative of our cost function. It helps you to guess best parameter for your model. Okay, so you take out a partial derivative of cost function, and partial derivative is just like this. You simply tweak the parameters. You simply tweak a little bit parameter and see if your cost function is changing or not. It's just like the slope. Okay, so I'm not going to go in deep. So here you simply get the classification error and you update the weights of generator. Okay, and for individually also, and if classification, this discriminator also have to improve themselves, so it also take the partial derivative and updates the weights of the discriminator. Okay, but this is an overview of how actually all those things works, and I hope that you got very intuition, simply intuition about GANs. And again, GANs are on a boom topic. I urge you to simply learn this kind of tech which is available, or the kind of framework which is available in machine learning or deep learning. I will urge you to do that. And I'm also reading a research paper, very exciting thing. And what I've done is on my YouTube channel, by the way, my name is Ayush Singh. So by the way, on my YouTube channel, New Era, on the first week of June, maybe the second week of June, in June, I'll be publishing 8 hours of generative adversarial networks with mega projects. Means I'll be from very basics, means deep learning topic, what are neural networks, convolutional neural networks, etc. We will cover prerequisites, and then we'll go on to our first GAN, understanding more intuition about GAN. Then we'll move on to DC GAN, and then a little bit more advanced concept, and we will learning these all by making projects. And this is term called project-based learning. You'll be building an enormous number of projects, means generating handwritten digits, generating faces, image to image translation, text to image translation, etc. And I'm very excited for that course. Currently, video is going on, so my aim is to only make you familiar in this video is to make you familiar with what actually GANs is. So you should start exploring that. Okay, so I think that you got a fairly intuitive idea what I'm trying to convey you with that. Okay, so you can also go onto New Era YouTube channel. My link in the description box below. You can take a look at that and ask me any kind of question. So my New Era YouTube channel will be there, the link in the description. You can simply go there, have the bookmark that, and whenever I will publish, you can be notified over there. Okay, so thank you for seeing this video, and again, do not forget to explore that GANs. I'll be catching up in the next great tutorial, and then bye bye.